Pre- and post-privatization assessment of Transcorp power gas turbine plants using standard key performance indicators. Abstract. This research work aims at assessing, using key performance indicators as recommended by the Nigerian Electricity Regulatory Commission, NERC, the performance of Transcorp Power Limited power plants, Ughelli, Delta State, for the period 2008 to 2015, to determine if the privatization of the PHCN has been effective. Parameters for assessing the gas turbine units and the overall station performance were collected from the power station. These data, which includes installed and available capacity of plants, number of hours run, peak load values, average generation in MW, number of trip records, heat supplied and energy generated by each gas turbine and the overall station, pre- and post-privatization of the facility, were collated and analyzed with the aid of Microsoft Excel Spreadsheet to obtain the needed results. Result shows that pre-privatization, 2008-2012, total energy generated by the station were valued at 1,510,988.0 MWh and 1,582,696.90 MWh in 2008 and 2009 respectively, as against 2014 and 2015 that were estimated at 2,804,067.20 MWh and 2,894,031.80 MWh respectively. Energy exported to the grid, pre-privatization, was estimated at 1,486,338.02 MWh and 1,539,157.35 MWh for 2008 and 2009 respectively, and post-privatization values were 2,671,872.20 MWh and 2,804,575.94 MWh in 2014 and 2015 respectively. The capacity factor peak values were 73.53% in 2008 and 71.6% in 2009, while 2014 and 2015 recorded all-time peak values of 89.24% and 81.23% by GTS 16 and 17 respectively. Generation Utilization Index in 2008, 2009 and 2010 averaged at 77.77%, 76.73% and 66.14% respectively, whereas it averaged at 85.34% and 76.74% for 2014 and 2015 respectively. There were also better performances in peak load values, number of hours run, etc., post-privatization than it was pre-privatization of Transcorp Power Limited, Ughelli. From these results, it can be inferred that the generating units were underutilized pre-privatization period. Keywords: Transcorp Power Limited, Nigeria Power Sector, Gas Turbine, Privatization, Thermal Efficiency, Power Generation, Gas Consumption, Power Privatization. Introduction. Substantial expansion in quantity, quality, and access to infrastructure services, especially electricity, is fundamental to rapid and sustained economic growth and poverty reduction. Yet, for the past 4 decades, inadequate quantity, quality, and access to electricity services have been a regular feature in Nigeria. 1. In Nigeria, access to reliable and stable supply of electricity is a major challenge for both the urban and rural dwellers. The challenge, however, is more significant in the rural areas where only about 10% of the population has access to electricity too. Nigeria's electricity demand far outstrips the supply, which is epileptic in nature. The acute electricity supply hinders the country's development and not only restricts socio-economic activities to basic human needs, it adversely affects quality of life. 4. The objective of the electric energy system is to provide the needed energy services. 3. Energy services are the desired and useful products, processes, or indeed services that result from the use of electricity, such as for lighting, powering of electrical appliances, etc. 5. The electricity consumption in Nigeria is extremely low due to inadequate supply. As of 2011, electricity consumption stood at just 149 kWh per capita 6 and dropped to 144 kWh by 2014 7. At 149 kWh per capita, Nigeria's electricity consumption is one of the lowest in the world, about 4 times less than the African average, 563 kWh per capita, and 17 times less than the world's average of 2596 kWh per capita. 8. Most of Nigeria's power facilities were being managed by the defunct Power Holding Company of Nigeria, PHCN, a public sector charged by law for the generation, transmission, distribution, or marketing and sales of electricity to the public in Nigeria. 9. Until the Electric Power Sector Reform, EPSR, Act of 2005 and the consequent unbundling and privatization of the sector that has permitted independent power producers, IPPs, to obtain licenses to generate electricity. Prior to privatization and unbundling process, Nigeria's electricity generation has always hovered between 2,000 to 4,000 MW of available capacity. Not much has changed after the privatization process. This forms the background of study for this research work, to overview the power sector and assess with some performance indicators associated with the gas turbine power plants, the performance of Transcorp Power Limited, Ughelli, pre- and post-privatization, ascertaining if the unbundling process was a step in the right direction. Fig 1 is a schematic of the unbundled power sector. 2 gas turbines in Transcorp Power Limited, Ughelli, Delta State. The station was built in 1964 with an installed capacity of 2x36 MW, 72 MW, from 2 Still Laval gas turbines. Then, the station was called Delta I under Electricity Corporation of Nigeria, ECN. In 1975, 6 units of General Electric, GE, frame 5 gas turbines, 20 MW each, were installed in the station known as Delta II, after the merger of Niger Dam Authority, NDA, KNG, and the ECN to form the National Electric Power Authority, NEPA. In 1978, additional 6 units of GE frame 5 gas turbines, like the ones installed in 1975, were added, known as Delta III, to boost the installed capacity to a total of 312 MW, as follows. Delta I, 2x36 72 MW Delta II, 6x 2120 MW Delta III, 6x 2120 MW total 312 MW. The station was upgraded in 1991 with the addition of 6x 100 MW, 600 MW, GE frame 9 gas turbines. From 2000 to 2008, Delta II and Delta III GE units were upgraded to 150 MW station each, built by Hitachi of Japan. The control systems were upgraded to Mark V, a fully computerized control system for Delta II and III. While Delta I was scrapped. Delta IV control system was also upgraded to Mark V by GE of USA, which built the station. Today, the installed generation capacity of Transcorp Power stands at 900 MW. Most of the electricity produced by Transcorp Power is transported through a network of conductors, to the national grid. A generators in Transcorp Power Limited, Ughelli. Delta II and Delta III are horizontal shaft types and have ratings of 11/11.5 kV from original manufacturers. Siemens and Maidensha, with an operating speed of 3000 rpm. Delta IV generator is a horizontal shaft with torque adjuster and coupling. B. Raw materials for production. Transcorp Power Ughelli gets supply of natural gas from Shell Petroleum Development Company, SPDC, for Delta II and III at a gas pressure of 21-22 bars, and Nigeria Gas Company, NGC, for Delta IV at a gas pressure of 19-21 bars, but both SPDC and NGC can complement each other in times of emergency through a tripartite gas line valve. The other major raw material is the atmospheric air that is filtered and compressed. Part of the air is used for cooling and atomization of the diesel fuel, where need be, for combustion during operation. Most part of the compressed air is used for the combustion in the combustion chambers, with the natural gas. Hydrogen is used in cooling the heavy generators at Delta IV because of the enormous heat that the generator windings emit. Hydrogen cools 10 times better than air, hence its preference for air despite its high inflammability. The hydrogen is generated locally, from the electrolysis of water. Lube oil or lubricant oil is used in the gas turbine station for lubrication of the bearings, for hydraulic pressure and heat extraction. See components and auxiliaries of the gas turbine plants at Transcorp Power Limited, Ughelli. Method of electricity production. The gas turbine use natural gas and compressed air as fuel to burn and rotate the shaft that turns the generator, thereby generating electricity. Excitation is necessary to produce the required magnetic flux. Most of the electricity is transported through step-up transformers and network of conductors to various locations around the country in the form of grid. Some parts of the electricity are utilized locally within and outside the plant. F. Hydrogen gas production plant. Hydrogen gas, H2, is produced in the station for cooling the heavy General Electronics, GE, turbine generators of Delta IV. Plant details. Model, 00700. Capacity, 2x15 nm3/h. Frequency, 50 Hz. Date of commissioning, 1998/1999. G. Anti-fire system. The plant is equipped with sprinkler and hydrant fire-fighting systems with automatic code 2 high-sensitive flame detector and combating mechanics for fire emergency. H. The station switch yard. The Delta 4 330 kV high yard is configured to 1.5 breaker system to evacuate generated electricity from 6 units of 6x 100 MW, 600 MW, of the plant into the national grid for onward distribution to power consumers. 10. 3 Materials and methods. Ughelli Power, now Transcorp Power Limited, Ughelli, Delta State is among the 18 electricity successor companies unbundled from Power Holding Company of Nigeria, PHCN. Owing to various changes in the federal government policies in the electricity industry from 1973 to 2009, Transcorp Power has on various occasions changed its name and outlook. 3.1 Overview of Transcorp Power Limited. I. Over 52 years of service. 2. Transcorp Power has 4 power plants, Delta I, Delta II, Delta III and Delta IV, with the Delta I retired. 3. Transcorp Power has an installed capacity of 900 MW. 4. Custom-fitted engine starters in Delta II and Delta III turbines enables the station to black start the national grid in case of emergency or cases of total or partial system collapses. V. Transcorp Power provides auxiliary facilities for staff, such as staff housing, Medicare, school, and recreational club. 6. Transcorp Power Limited has 5 major departments: the Operations Department, the Efficiency Department, Performance Management and Planning Department, Health, Safety and Environment Departments, Plant Maintenance Department, which includes Mechanical Maintenance Department, Electrical and Control Department, Protection, Communication and Metering Department, Workshop Services Department, Civil and Estate Department. 3.2 Description of each station. Delta I. This station used to house the 2 number Stoll-Laval units of 36 MW each. These units have since been scrapped. Plans existed for fresh packaged gas turbines installation in the spaces provided. The main blocks of Delta 1 serve as offices of the 2 assistant general managers, plant services and production, some other principal managers and mechanical/vehicle workshops. The operational switchings in Delta 1 and 2, 132/33 kV, high yard are performed by the TCN operators, while the local lightings for the offices in Delta 1 and around are powered from the switch yard through the 33/0.415 kV transformer. The radiating feeders in Delta 1 switch yard include I. Benin 132 kV line 1 and 2. 2. Efurun 132 kV line. 3. Ughelli Old Road 33 kV feeder. 4. Isoko/Ughelli 33 kV feeder. Viag Barho/Aku 33 kV feeder. 6. Alaja 33 kV feeder. 7. Shell 33 kV feeders 1 and 2. These 33 kV feeders are served through 2 NOS 132/33 kV, 45/30 MVA, transformers. Delta 2. This station comprises of 6x25 MW, H25 Hitachi, units, on a total installed capacity of 150 MW, GTS 3, 4, 5, 6, 7, 8. The station is served gas mainly from SPDC Ughelli East Gas Plant at pressure ranging from 20 to 22 bars. Some of these GTS often trip on faults involving compressor, bleed valve position problem, exciter problem, starting, diesel, problems etc. GTS 3 and 5 has been out of service since 2007 due to generator fault caused by wrong phase termination between the 132 kV main bus, transformer, and units generators. GT4 was out of service due to starting device problems and confirmation of 81 MVA transformer, T3, status from TCN since 2007 but came into operation in 2011. Delta 3. This station also comprises of 6x25 MW, H125 Hitachi, units on a total installed capacity of 150 MW. The units operate on natural gas pressure range of 20-22 bars from mainly SPDC Ughelli East Gas Plant. The main problems that occur on the Delta 3 units are similar to that of Delta 2. Such problems include inadequate gas supplies from SPDC, major excitation problems, Mark V, uninterrupted power supply, UPS, and monitor failures, vibration, oil leaks etc. The source of supply to the units on cranking motor on 3.3 kV is still on temporary facility from Delta 4, 132/3.3 kV, Starting transformer. Efforts should be made to install a separate and permanent source from Delta 3 switch yard as originally designed. Lack of statutory inspections on the units based on exceeded expected operating hours, EOH, is likely to cause unpredicted outages on these units with time. Delta 4. This is a station of 6x100 MW, GE, units on a total installed capacity of 600 MW. Common problems in Delta 4 pre-privatization include cooling water pump failures, 2 cranking motor failures, 3 accessory gearbox failures, 4 hot exciter/PCC rooms, V-torque converter failure, 6 flame detector/ignition failures, 7 hydrogen leaks problems, 8 oil ingress to the generator due to oil seal damages, 9 seal oil differential failure, X air inlet filter problems, 11 exhaust system failure. 10. 3.2 Operation data used for analysis. With the ongoing government effort to boost power generation in the country, it is very important to monitor the performance of operating generation companies in the country and assess whether they are making use of their resources efficiently and effectively towards electricity generation. The parameters used for this assessment and comparative analysis of Transcorp Power Limited are the recommended key performance indicators, KPI, from National Electricity Regulatory Commission 11. The monthly/annual generation performances are dependent on these factors. Energy generated, MWH. This gives account of the daily, monthly, and annual energy production from the available plants for the periods under consideration. It is a measure of the energy generated in MW and the number of hours, run, H. 2. Energy consumed, MWH. Energy consumed in MWH is an account of energy that is used in-house at Transcorp Power Limited for powering major equipments, facilities, and offices. 3. Energy exported, MWH. This gives account of the value of energy sent out in MWH to the national grid for onward transmission and distribution. Most of the electricity is evacuated through step-up transformers and network of conductors through various locations around the country. Energy exported to the grid is simply energy generated, MWH, less energy consumed in the stations. 4. Running hours. This denotes the recorded time in hours run by each plant for the periods under consideration. V-unit trip records. Trip records show how much frequency each unit was not under operation due to several reasons ranging from maintenance to damage. Higher trip records for a unit plant would contribute to poor performance and low percentage contribution of the plant to the station's generation. 6. Gas supplied and consumed by the station. Transcorp Power Limited, Ughelli gets supply of natural gas from Shell Petroleum Development Company, SPDC, for Delta 2 and 3 at a gas pressure of 21-22 bars, and from Nigeria Gas Company, NGC, for Delta 4 at a gas pressure of 19-21 bars. Both SPDC and NGC can complement each other in times of emergency through a tripartite gas line valve. 3.3 Methodology. The following parameters were used in assessing individual units and overall station performance within the periods under review, 2008 to 2015. These key performance indicators, KPIs, provide a useful measure of how well a power plant is operated and managed. Data for this study were obtained from Transcorp Power Gas Turbine Power Stations Data Bank via the assistance of the company's efficiency department. These are inventory records of monthly energy generation between 2008 and 2015 and operational statistics showing the period when each of the plant units had major outages. Data collected includes I. Energy generated in MWH. 2. Energy consumed in MWH. 3. Energy exported to the grid MWH. 4. Gas consumed in standard cubic foot, SCF. V. Unit trip records. 6. Load factor. 7. Installed capacity and available capacity in MW. Equations employed for this work are as contained in 12. 3.3.1 Capacity factor, CF. The extent of use of the generating plant is measured by the capacity factor, CF, which is the ratio of the average energy output of a unit plant for a given period of time to the plant capacity. Thus, the characteristic behavior of generating plant depends substantially on the capacity factor and utilization factor. High capacity factor is desired for economic operation of the plant. Values of capacity factors are normally expressed in percentages. 3.3.2 Availability factor, AF. This is the ratio of the actual time the unit was in service to the total interval under consideration. The more the availability factor, the better the total output and performance. Values are best expressed in percentages. 3.3.3 Load factor, LF. This is the ratio of the average load to the maximum demand for a particular period. Since the average load is always less than the maximum demand, load factor is always less than unity. Load factor values are expressed in percentages. Since facilities likely never operate at full capacity for the duration of an entire 24-hour day, a high load factor means power usage is relatively constant. 3.3.4 Generation Utilization Index, GUI, otherwise known as the utilization factor, is the ratio of the maximum demand to the rated capacity of the power plant. The utilization factor measures the use of the total installed capacity of the plant. Values of GUI are best expressed in percentages. Higher values indicate a better performance and effective utilization of plants. 3.3.5 Units contribution to station's total output, UCT. This is the ratio of the total energy generated by a unit, plant, in a given time to the total energy generated by the station in the same period. A higher percentage contribution to the total output by a plant means a desirable performance of that plant. These values are normally expressed in percentages. 3.3.6 Thermal efficiency. This simply represents the fraction of heat in terms of gas supply that is converted to work, energy generated. It is a dimensionless performance measure of a heat engine that uses thermal energy. In general, efficiency of even the best heat engines is quite low. Best thermal efficiency usually is less than 40% due to several reasons ranging from power required to drive the compressor, friction and heat losses, design inefficiency, etc. Assumptions. Each unit is allowed 10 days for combustion inspection, therefore the total running hours in a year is 24 hours x 365 to 10 equals 85 20 hours. 2. Each unit is expected to operate at its installed capacity 12. Results and discussion. The summary of the data obtained is shown in the figures below. 4.0 Discussions. 4.1 Energy generated. As clearly tabulated and shown in Table 1 and 2 and Fig 3 in 2008, the total energy generated was 1,51098.00 MWh out of 10 functional gas turbine units. In 2009, total energy generated was 1,582,696.90 MWh from 10 functional units also. 2010 had a total energy generated at 1,954,793.40 out of 12 functional units. 2011 had a total of 1,488,116 MWh less than what was generated in 2010. A total of 11 gas turbine units were functional. Best performance was from Delta 4 and a peak generation was got from GT20. In 2013 there was an increase in generation better than the previous year in 2012, which recorded 1,328,219.50 MWh. 1,692,883 MWh was recorded in 2013. Post privatization, generation skyrocketed to 2,804,067 MWh in 2014 with an increase in GT availability to 12. GTS 5, 6, 10, 11 which were not performing in 2013 were revived to their maximum performances. In 2015 an all-time generation of 289,403 MWh was witnessed, highest value recorded so far in Transcorp Power Limited within the years under review. Other non-operational GTS such as GT9 and GT18 which did not perform in 2014 were also revived. Maximum monthly generation was recorded in January 2015 valued at 295,716.50 MWh and 271,001.6 MWh in May 2014 as against 179,863.90 in January 2008 and 231,089.10 MWh in June 2010. 4.2 Energy consumed. As shown in Fig 4, total energy consumed in 2008, 2009, 2010, before privatization, were 24,649.98 MWh, 43,539.55 MWh and 53,353.99 MWh respectively as against 132,194.40 MWh and 89,455.86 MWh recorded in 2014 and 2015 respectively. The increased consumption values could be likened to the corresponding increases in generation values. Higher generation would result in a higher energy consumption values over same period. Energy consumed refers to the energy used up in the facilities for administrative works and also for powering other auxiliary equipment in the plants like the hydrogen plants, filtration machines etc. 4.3 Energy exported to grid. Fig 5 shows a representation on energy exported to the grid. Energy exported to the grid is a huge function of what is generated by the station. Pre-privatization shows a record of 1,486,338.02 MWh, 1,539,157.35 MWh and 1,901,440.40 MWh for the year 2008, 2009 and 2010 respectively. Post-privatization of Transcorp Power Ltd, higher records of 2,671, 872.20 MWh and 2,804,575.94 in 2014 and 2015 respectively. Maximum values were obtained in July 2014 and January 2015 valued at 262,343.00 MWh and 284,660.20 MWh respectively. 4.4 Number of hours run. Tables 1 and 2 shows the total number of hours run in 2008 by the units was 57,377 hours, it dropped to 43,853 hours in 2009 and rose again to 65,609 HRS in 2010. Compared to post-privatization values, 2014 recorded 69,291 HRS while 2015 has a record high of 84,833 hours. Peak value was recorded by GT10 valued at 7,515 HRS in 2015 as against 7,422 and 7,033 recorded by GT9 and GT20 in 2008 and 2009 respectively. 4.5 Capacity factor. Tables 1 and 2 shows detailed information on the comparison of capacity factors pre- and post-privatization of Transcorp Power Limited. The maximum capacity factor for 2008 was recorded by GT6 and valued at 73.53%. It was valued at 71.6% by GT20 in 2009. Compared to post-privatization value in 2014 at 81.23% by GT17 and 89.24% by GT16 in 2015. 4.6 Availability factor. Tables 1 and 2 shows that availability factors were better post-privatization as seen in 2014 and 2015 when compared with previous years. Value as high as 98.94% and 98.47% were recorded for GT4 and GT12 respectively. 2015 has values as high as 88.32% and 84.51% for GT8 and GT13 respectively. 2014 value for GT12 met the industry standard of 95% compared with previous work on other gas turbines as cited. Availability factor, percent, is relatively fair. 4.7 Load factor. Fig. 8 shows detailed information on the comparison on peak load and load factor values pre- and post-privatization of Transcorp Power Limited, Ughelli, Delta State. It can be seen that the load factor records were more impressive post-privatization on the average. January 2014 had an all-time value of 90.06%, also 89.79% in April 2014. 77.29% was recorded in November 2015. These are against peak record of 75.1% in November 2015, pre-privatization. International best practice as cited for load factor is 80%. Post-privatization values of 2014 exceeded the standard unlike in the other years. 4.8 Unit contribution to station's total output. Tables 1 and 2 shows detailed information on the percentage unit contributions pre- and post-privatization of Transcorp Power Limited. 2008 and 2009 for GT12 were valued at 4.01% and 4.77% respectively. Individual units generation in MWh were valued at 60640 MWh and 75505 MWh for 2008 and 2009 respectively. Almost double the energy generated in MWh were obtained post-privatization by the GT12 in 2014 and 2015 respectively, but the percentage contribution in 2015 is only 3.97% in relation with the total energy generated in MWh in same year. 2014 value was much higher than in 2015. It was valued at 5.3%. A look at the performance of each gas turbine unit to the station's generation as shown in tables 4.14 to 4.16 reveals that GT2, which has been unavailable pre-privatization, was resuscitated to maximum performance post-privatization. Same also were the cases of GT13 and GT19. On the other way round, GT14, which was at its best performance pre-privatization, has not been functional post-privatization of Transcorp Power Limited for the periods under review due to persistent blade failure which has lingered since 2011 due to parts unavailability for the original manufacturers. In general, a total of 10 gas turbines were operational pre-privatization as against 12 and 14 fully operational turbines post-privatization in 2014 and 2015 respectively. 4.10 gas supplied and energy generated. Fig. 6 shows clearly that much volume of gas was supplied post-privatization, 2014 and 2015, which equally resulted in the improved total generation, MWH, than in the previous years. 4.11 Thermal efficiency. Fig. 9 shows that thermal efficiency of plants post-privatization outweighs their performance prior privatization. January 2014 has a recorded all-time value of 33.85% and 31.66%, 31.33% in February and March, respectively. 2015 equally recorded high thermal efficiencies of 29.78%, 29.93%, and 29.48% in July, September, October, and November, respectively. This is as against peak values of 25.06% in July 2008 and 28.32% in October 2009. 5.1 Conclusion. Privatization of the power industry has been argued and adopted as a step in the right direction towards achieving stable electricity. In this study, from the data analysis carried out and findings in Transcorp Power Limited, Ughelli, one of the privatized power generating companies in Nigeria, some interesting results turned out. Energy generated in megawatts-hour after the company has been completely privatized, 2013 to 2015, far outweighs what used to be obtainable. Total energy exported to the national grid for onward distribution equally improved tremendously post-privatization of Transcorp Power Limited as against what has always been obtainable over the past decade. There were great improvements also with regards to unit contribution to station generation post-privatization of the station. Most of the abandoned units came back to their maximum performances, percentage generation to installed station capacity also saw an increase. Also recorded was an improved generation and thermal efficiency of the plants post-privatization. The number of hours the plants were in operation post-privatization far outweighs their values pre-privatization as seen from the availability factors recorded. Post-privatization values of the generation utilization index, capacity factors, and thermal efficiencies of plants were equally more desirable than it were pre-privatization. From the aforementioned findings, it suffices to say that privatization has really paid off in Transcorp Power. It could be inferred that management under the private sector is way better than it was with the government. 5.2 Acknowledgments. I appreciate the management of Transcorp Power Limited, Ughelli, for their unwavering support to academic research. Special thanks to the operations manager, Ingrid Clifford Ago, and the efficiency department in charge, Ingrid Ndubisi Alaja. I will extend my regards to Professor A.I. Obanur, Ingrid Henry Egware and Dr. E.G. Sajara of the University of Benin, Edo State, Nigeria, for their guidance towards achieving this research feat.